Hey everyone, and welcome. I am absolutely thrilled to have you here for today's explainer. If you're a focused learner trying to wrap your head around the massive shift happening in the energy sector right now, well, you're in exactly the right place. Today, we're taking a deep dive into how the oil and gas industry is fundamentally transforming. We're talking about an industry historically defined by heavy machinery and physical limits, shifting into an era defined by digital abundance. Okay, let's jump right in.
I want you to picture this for a second. What happens when an entire industry is literally drowning in data, but only actually uses 0.5% of it? It's kind of a mind-blowing paradox, right? Oil and gas companies have hoarded massive amounts of information over decades of operations, but they are absolutely starving for real, actionable insights.
Let's look at where all this is coming from in Section 1, the data torrent. To really grasp the scale of this torrent, just look at modern operations. A single, newly built refinery can have up to 25,000 individual sensors. And these aren't just jotting down a daily log. They're firing off measurement data every single second, every single day. That is a relentless, non-stop flood of information detailing temperature, pressure, flow rates, you name it. And honestly, it's not just the refineries. Out in the field, a standard industrial survey flight generates a staggering 1 terabyte of data all by itself. Plus, as autonomous vehicles become standard in the oil field, they're going to be continuously pumping out similar massive volumes of information.
But here is the big reveal. Despite the terabytes and petabytes of data flowing in from those sensors and vehicles, most oil and gas companies openly admit to this harsh reality. They utilize a mere 0.5% of the data they collect. That means 99.5% of this incredibly valuable operational history is just sitting there, totally unused, locked away in digital filing cabinets gathering virtual dust.
To fix this, we kind of have to redefine data itself. Historically, the industry dealt with large data, massive volumes of structured data, the stuff that fits perfectly into the neat little rows and columns of traditional spreadsheets. But today, we're living in the era of big data. This is messy, complex, unstructured stuff. We're talking text messages, high-res photos, drone video feeds, and even acoustic vibrations. Your basic spreadsheet simply cannot handle this.
Let's bring this down to earth for a minute. Historically, the industry was basically defined by dumb iron. This is the world of physical constraints, where your progress was literally limited by the size of the pipe, how hot the furnace could get, and just the sheer heavy metal reality of the job.
But flip that script. When you start overlaying digital networks onto those physical assets, everything changes. We enter a world of abundance. We're moving into an environment where data storage and processing power are, for all intents and purposes, infinite and practically free. The constraint isn't the physical metal anymore. It's our ability to process the digital information surrounding it. So how exactly do we process that flood of data? That brings us to Section 2, the analytics spectrum. We lean heavily on what you could call cheap math, abundant computing power. The first stage here is descriptive and diagnostic analytics. This lets managers look backwards to figure out exactly what happened and, more importantly, why it happened. For example, by using AI to analyze historical data, companies actually found hidden 20% energy use reductions in data centers. These were massive efficiencies that human modeling had entirely missed.
Now, the next step on the spectrum is predictive analytics, and this is where things get super cool. This is about identifying equipment failure before it actually happens in the real world. By slapping sensors onto that dumb iron we talked about, companies use predictive math to foresee which pumps are about to fail. Catching that early can lead to a massive 90% reduction in unplanned equipment downtime.
Then we have the final, most advanced stage, prescriptive analytics. This relies on next-gen ERP systems like SAP HANA to deliver in-the-moment analytics. It doesn't just predict what will happen, it actually prescribes exactly what you should do about it right then and there. It empowers operators to make vastly better decisions while a process is actively running, rather than scrambling to fix things after the fact.
Moving right along to Section 3, strategic upstream use cases.
Let's see how this spectrum works in actual exploration. It's really all about teaming up human expertise with machine speed. Take drilling optimization, for example. In the past, highly trained engineers would spend like 40% of their valuable time just cobbling together data to set up a drilling program. Now, AI does this in a flash. It sifts through massive data sets of prior costs, well logs, and seismic data to instantly pinpoint the optimal sweet spots. And once drilling starts, smart drill bits capture real-time formation data, compare it against huge historical records, and basically guide the physical operations as they happen.
The ripple effect of this is staggering.
By using machine learning to understand things like reservoir porosity, permeability, and fluid behaviors, producers can build highly accurate decline curve models. They know exactly when and how to intervene to keep production pumping. In fact, the International Energy Agency estimates that using these digital techniques on unconventional resources could actually expand global reserves by a full 5%. That is a truly gargantuan number on a global scale.
Which leads us perfectly into Section 4, Visualization and Real-Time Action.
Look, here's a golden rule of big data. All this fancy math is completely useless unless humans can easily understand it. Data only becomes actionable when it's presented the right way. And one way we're making it actionable is through mobility and augmented reality. Operators aren't chained to a central control room anymore. They use mobile dashboards on tablets and smartphones to monitor pressure and temp. Out in the field, sensors broadcast wirelessly straight to a cloud dashboard. We're even seeing augmented reality deliver warning pop-ups right in a worker's field of view, letting them know if equipment is energized or safely highlighting the exact parts they need to service.
And it gets even more sci-fi when we talk about immersive simulation. By using advanced digital twins, engineers can now literally put on a headset and fly through a full 3D hologram of a massive physical asset. They can do this during turnaround planning to spot space constraints or bottlenecks long before a single worker ever sets foot on the actual site. Ultimately, this digital innovation completely flips the old industry orthodoxy that only people can control infrastructure. By merging information technology with operational technology, we can have drones autonomously fly over a well, grab raw data, process it in the cloud, and automatically spit out tangible results, like highly specific work instructions and optimized shift plans for the crew, all based on real-time status. All right, let's talk numbers in Section 5, the economic bottom line.
At the end of the day, there is a huge financial incentive to automate all this routine brain work. By fully leaning into this digital paradigm, companies are targeting a remarkable $3.30 per barrel savings. In an industry where margins can be tight and volumes are massive, $3.30 a barrel is an absolute game changer.
So where exactly does that cash come from? Let's break it down. $1 full of that savings comes simply from having clean, consistent data that streamlines work planning. Another 90 cents per barrel is saved by using robotics to physically displace routine, repetitive labor. And the rest? That comes from the broader efficiencies of the automated analytics we've been talking about.
To sum up the technical journey of this explainer, the most successful oil and gas companies of tomorrow won't just be drillers. They're going to act a lot more like orchestra conductors of data. By orchestrating this massive flow of information, they can actively leverage analytics to boost their overall asset utilization by up to 30%.
But I want to leave you with this final kind of provocative thought. Throughout this whole explainer, we've seen that the computer power, the sensors, the cheap math, that's actually becoming the easy part. The truly hard part, the challenge that will absolutely define the winners and losers here, is human. How do we successfully manage the massive workforce transition required to fully trust and embrace these data-driven decisions? It's a fascinating question and one this industry is going to be wrestling with for years to come. Thanks for learning with me today on this explainer, and keep staying curious.